When you're programming in Go, error handling can sometimes feel like, well, a chore, right? A lot of if error not equal nil. But what if I told you there's a way to turn that chore into one of your most powerful architectural tools? Today, we're going to explore a really simple but kind of profound shift in thinking that can completely change how you write Go code for the better. So our story starts here. We've got a junior developer, let's call him Ethan. He's staring at a screen, totally frustrated. He's building something that has to sync with a pretty flaky API, and his retry logic, it's just spiraling out of control. He turns to his senior colleague, Eleanor, points at his code, and just says this. All right, so let's take a look at this monster. The real problem is how Ethan is checking for errors. He's got this long chain of if statements, and in each one, he's trying to figure out if an error is a temporary one so he can try the operation again. But as we're about to see, this whole approach is just creating a bigger and bigger mess. And here it is, the code that's causing all the trouble. It is a long, ugly chain of if statements. See how each one is using errors is? That function checks if an error in a chain matches one specific known error. The big problem here is that this code is super brittle. It's tightly coupled to the network library. So if that library adds a new kind of timeout error tomorrow, well, Ethan has to come right back here and add another if check. It's just not scalable. It's a total maintenance nightmare waiting to happen. And this is where Eleanor, the senior engineer, drops the piece of wisdom that changes everything. This one sentence is the whole mental shift. It's the key idea that's going to help Ethan tame that monster in his code. So let's really break down what she means. It's all about moving from checking an error's identity, asking what specific error is this, to checking its behavior, asking what can this error do? They sound similar, but they're two completely different ways of looking at the exact same problem. And this comparison makes it crystal clear. On the left, you've got identity. Using errors.is like asking, are you exactly this thing, like error connection refused? It's super rigid. But on the right, you have behavior. This approach uses interfaces, and it's like asking, hey, error, do you have the capability I'm looking for? Can you tell me if you're temporary? It's way more flexible, way more abstract. And this brings us to a more formal definition. This whole idea is a design pattern called behavioral error handling. Your code stops caring about the specific type of error or where it came from. All it cares about is what that error means or what capabilities it has. And that right there is the foundation for a much, much more robust system. Okay, so how do we actually do this? Well, the tool for the job is super elegant, incredibly simple, and honestly one of the most powerful features in all of Go, the one method interface. Just look at this. That's it. That's the entire contract. It's just an interface we're calling temporary, and it has a single method, also called temporary, that returns true or false. Any error type out there that implements this simple method automatically fulfills the contract. It's a clean, simple signal. And this is what makes it so brilliant. It doesn't matter where the error came from. It could be a database package, a network client, a rate limiter, whatever. As long as the person who wrote that error gives it a temporary bool method, it satisfies our interface. The different parts of your system don't even need to know about each other. They just need to agree on this simple contract. All right, this is all great, but there's still a piece missing. In Go, errors are often wrapped inside other errors to add more context. So how do we find our little temporary behavior when it might be buried like 3 layers deep inside an error chain? And that is exactly what Ethan is thinking. He gets the logic, but he's worried about how to actually write it. Is he going to have to write some complicated loop to dig through every single layer of a wrapped error, checking each one along the way? Thankfully, the answer is a big, resounding no. And here it is. This is the solution from Eleanor. She replaces that entire monster if statement with these 3 beautiful, elegant lines of code. All she does is declare a variable for our temporary interface and then uses a standard library function, errors.as, to see if the error chain has something that fits the bill. It's clean, it's concise, and it is so, so powerful. So how does this little magic trick work? Well, the errors.as function is smarter than you might think. It's not just for checking concrete types. When you give it a pointer to an interface variable, it automatically walks through the entire error chain for you, and it looks for the very first error that implements all the methods of that interface. This is my absolute favorite way to think about it. Imagine a wrapped error is like one of those Russian nesting dolls. Errors.as is the function that opens up each doll one by one and asks a simple question. Can you be temporary? The very first time it gets a yes, its job is done. It's like a built-in search party for behavior. So let's zoom out a bit, because this is way more than just a clever coding trick. This fundamentally changes how the different parts of your application talk to each other. And that leads to a much cleaner, way more maintainable design in the long run. Let's break down this huge win. First, the producer of the error, say the network package, is the one responsible for defining the behavior. It's their job to add that temporary method. Second, the consumer of the error, our business logic, it just asks for that behavior. And the result? Boom. Our retry logic is now completely decoupled from whatever specific thing caused the error. And this, right here, is the ultimate point. Your business logic gets so much simpler and more focused. It stops caring about who made the error and only cares about the behavior it needs to handle. You don't have to import a dozen different packages just to check all their specific error types anymore. All you need are clear behavioral contracts. And that's the transformation. By adopting this one simple pattern, Ethan totally changed his code. What was once a fragile, growing liability, a source of future bugs and late-night fixes, it became a robust, flexible, and intentional piece of his software's architecture. And so I'll leave you with this question to take back to your own projects. Think about those complex if statements, those long error checks you've written. Where in your code can you stop asking what an error is and start asking what it can do? Because that little shift in thinking might just be the architectural upgrade you've been looking for.